We're live, I think. Okay, we're live. This is Toby, and welcome to the show where we make a programming language on stream. This time, my plan, I don't know about yours, but this time my plan is to add arrays to the language. I'm calling it implement arrays. This is my little window where I am gonna do sub goal labeling. So I'm gonna sort of highlight the current task that I'm on at any given moment. Hopefully, I remember to update my progress here. So yeah, let's get into it. I'm gonna implement arrays. So that involves first adding the parsing for array literals in the language, and then after I have that and have the AST update parser plus generate AST for arrays literals. So after I have that, then I'll need to update the code generator in order to translate my arrays, the arrays of the X programming language, to the arrays of JavaScript, so that the uh, the actual generated JavaScript program works as intended. After that, I think in order for the arrays to be useful in the language, then I'm gonna probably add in map, filter, and reduce built-in functions. Another idea might be implement for loops, but I'm kind of feeling like so far the language has taken a very functional turn. It's not necessarily because of philosophical reasons, but it's more just because of practical reasons, because it's easier to get somewhere where you can do interesting things with the language if you don't have to implement a lot of operators. If you just leverage functions, sort of use the functions as operators, so to speak. So I think I'll continue that trend at least for a bit. We'll see what happens. If we're lucky, we might even do dictionaries. I don't know. Okay, so let's get into it. I'm gonna go into my. I have a suspected spammer calling me, so I'm gonna ignore them. Okay. I'm not totally sure about this setup. I think I'm gonna do it like this. Okay. All right. Oh yeah. If you, by the way, if you are new to this project, you can find the code that's written on this stream on GitHub here, github.com/airportyh/xlang. Yeah, let's get into it. So I'm gonna need an array syntax. I made a full example a while ago. Uh, all of this has not been implemented, but this is a sketch of some of the ideas about what might go into this programming language. And I was thinking arrays are gonna look like this, which might be unconventional. Well, actually C and C# do it kind of like this with the curly bracket. At the beginning of this series, I said I was gonna stay away from curly brackets, but last episode I decided to use them for arrays and dictionaries. Um, to resolve this conflict I was having between if I want code blocks to look like this, and I'm also gonna make array literals use the square brackets, then from the parser perspective, there's a very large ambiguity. So yeah, I'm gonna go with this. So okay, start, and at the moment I'm gonna select the update parser and generate AST for array literals. That's what I'm doing now. So I'm gonna color that like blue. Yeah, right. Maybe make it bold as well. Okay, so that's what I'm doing. All right, so the grammar of this project is, where is the grammar? So I'm gonna basically add an array literal. Oh, let me check the lexer first, because first the string goes to the lexer, and at the moment lexer doesn't know about curly brackets, so let's change that. I said left bracket. I called this guy a bracket. Maybe call the curly one a brace, so I'll call this left brace. It doesn't actually matter what I call it, because I don't actually reference the name, this name. In the grammar, I use the string literal, as you will see very soon. Okay, so I have left brace and right brace. Now the tokenizer will actually be able to make sense of curly braces in the language. Now I'm gonna add array literals as a thing, as a symbol in this language. Where should I put that? I have probably at the bottom, near the bottom, where my literals are. So we have number literals and string literals, which were parsed by the lexer, but the array literal will be parsed by the parser. Okay, so an array literal should look like this. There's first going to be an open brace, a left brace, and then we want some mandatory white space, I believe. Well, no, some optional white space. So I'm looking at parsing this guy, right? Maybe I should document this with, maybe each of these symbols should be documented. So with like an example. Well, you can't give an example of white space, but yeah. I just, yeah, I'm not gonna change the other ones. I'm just gonna do this one. Okay, so an array literal looks kind of like this. There's some optional white space, which is denoted by 1 underscore. Mandatory white space is denoted by 2 underscores. I'm considering the 3 underscores to mean mandatory, or I don't know. Like I need the concept of a white space that can contain a new line in it. Maybe that's 3 underscores, and then maybe white space that is mandatory and has a new line in it can be 4 underscores. I'm not sure. Let me think about it. Okay, so let's see. Array literal. There's a so after this optional white space that's here, and that I'm gonna have an expression, and then I'm actually gonna need a delimited list here of things, which I believe I've done that before. This is kind of what parameter list is. The function definition has a parameter list. A function call also has a parameter list. Oh, I have a feeling there's a problem here, because a parameter list Yeah. This parameter list for the function call should be distinct from the parameter list of a function definition, because a parameter list within a function definition, these can only be names, whereas this one can be any expression. So I'm gonna need to fix that at some point, but I'm gonna try to not do it right now because I don't want to sidetrack myself. So let's do this. I would like to rename parameter list to argument list, and then later I'm gonna recreate parameter list, but only use parameter list for the function definition while using argument list for the function call. So that's what I'm gonna do now. I'm gonna rename all usages of parameter list to argument list, replace all, and I hope that still works. I'm gonna regenerate a parser. Okie doke. Let me make this window bigger. Make this font a little bigger as well. Okay, so I have argument list now, and I'm just gonna say an array literal is actually a. I shouldn't even call this argument list. Maybe I should call this expression list. Okay, change my mind. Calling this expression list because from the perspective of an array literal, these are not arguments, these are expressions, maybe. Depends on how you want to use your nomenclature, define your nomenclature, I guess. But I'm going to call this an expression list. So yeah, so within an array literal, you can have this and an expression list. Yeah, I think that works. And then after that, we're gonna need to sort of package up these matches into an AST node. So I'm gonna get a data array, and I'm going to the thing I want is this expression list. So that's at index 0, 1, 2. So data index 2, that's what I want. And return an object of type array literal, and the items is whatever the expression list gives you. And now we have the array literal symbol, and I'm gonna say an array literal is also an expression. So an expression can be any of these things: an identifier, a literal, a function call, a code block, and an array literal. I think that probably works now. Let's try this. npm run gen parser. I'm going to regenerate the parser, and then let's make an example program that has an array in it. So I'm going to say example array.x. So I'll say arr equals 1, 2, 3, but I also have a couple of strings maybe in the array. Oh, maybe print the array out like that. See if that works. I will parse it. Node parse example.array. Oh, the parse tree generated multiple results. That's actually potentially very instructive because recently I got a YouTube comment. Let me see. I got a YouTube comment from someone asking, like, she's implementing a parser using Nearly.js, and she got a ambiguous grammar. So and she asked me how to solve that problem. And since I just got this exact same problem now, this could be instructive for her. as well as other people that run into this issue. Okay, so I'm gonna look at. There's a couple of ways to look at it. One is the first thing, probably the easiest thing, is to look at both of the parse trees, um, and see if you can get a clue there. See if the parse trees are different. And this printout doesn't show you all of the details, so because console.log, when you ask console.log to log a deeply nested JavaScript object, it'll only well, for Node.js, it only show you a certain level of detail, but you can change that by using the util. There's inspect method in this util package that comes out of the box. You don't have to npm install this guy. This is part of the standard library in Node, and you can, when you are printing out an object, you can actually say util.inspect, and you can give it a certain depth. I'm going to say depth 10, so that you can see more detail. Okay. I guess we can try to maybe look at whether these two things are different in some way. So in this case, I have an assignment whose value is an array literal, which looks correct to me. That's what I was intending. It's an array literal that contains these items. There's 3 numbers and 2 strings. Okay, and let's see. There's also a function call. Oh yeah. There's a function call with the calling the print function with the identifier of ARR. Yep. Okay. That's the first version of the parse. The second version of the parse is this. It actually looks quite the same to me. So I'm not really getting a hint here about what the problem is. Okay. So the first technique didn't really work out for us, unfortunately. But well, there's another technique. Well, there's more techniques. One is just try to figure it out by looking at it. And I will do that, but that's not as good. A better technique is actually use the tools to actually help you visualize what's going on. I'm actually gonna do that now. So it comes with there's a script called nearly test, I believe. Although I don't use this probably as often as I should. So I'm gonna go to nearly.js.org to look at how to use nearly test. Tooling, I believe it's under. Yeah, there we go. Nearly test. There's also nearly unparse, but I want to use nearly test. Okay. It doesn't actually teach me how to use it actually, so I'm gonna do help. So okay, so I'm supposed to put in some input. I could pipe input into it as well, I think. And then I need to provide it with the grammar.js file that was generated. Okay, so I'm gonna say nearly test, and I guess I need cat my program. Oh, on Windows it's a different, but or wait. On Windows, it might be different the way you pipe a file in, but I'm just gonna try, or I could, let me do one more thing. So I'm gonna remove the second line because chances are the ambiguity comes from the first line. So I'm gonna see whether I still get an ambiguity. That's a lot of output. Yep, we still have multiple results. So okay, so now that it's on one line, I'm actually gonna do it from the command line. So try to put in this whole command in the command line. Actually, I'm not sure this works because I have double quotes, but I will try. I might need to escape these double quotes like this, maybe, and then, but then I still need to give it the grammar file.js, and okay, it's given me, yeah, it's given me these parse results, 2 parse results, and I can actually see the parse tables. There's actually only one parse table that yielded both of the results, and you can actually, with some understanding of the nearly algorithm, you can actually make sense of what's going on here. I'm gonna plug in my tablet so I can draw. Give me a moment. Okay, I found my stylus. Okay, so now I can draw, I believe. Whoopsies. What? Oh, I need screen brush running. All right. Okay, so we're gonna try to make sense of this huge parsing chart. Let's see if we can. So there are two. First of all, this I'll just do a brief explanation of how to read the entries in this chart. So, by the way, chart 17, that is the position of input. I actually don't know what the current, well, the fact that I can kind of guess that we're at the end of the file because which is position 17 is probably here. Yeah, after, so yeah, I can count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh no, but it doesn't work that way. It's the position not based on this character, but based on tokens. Okay, so it's actually 1, and then the whitespace count is whatever the lexer gave you. So the lexer is going to separate it into, that is an identifier, that's a whitespace, that's an equal sign, that's a whitespace, that's a left brace, and so forth. So it's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the whole string literal is 1 token, and then 14 for that white space, 15, 16, 17, and then it does actually add up to position 17. So basically, after having parsed 17 tokens, actually, no, it's 16, so position 17, so we're off by 1. But at this point, at the point of uh, at the point of receiving the 17th token, which is that one, we were previously at this position where we're parsing an array literal, and it's like this dot is the cursor. So yeah, this guy is the cursor. So this is the current position. The current position of the parse. So because we have successfully sort of matched these things along the way of reading in the tokens, and the next thing we're looking for is just that. Oh wait, no, sorry. I read it completely wrong. So I should be ignoring this open brace and close brace. That's just part of the output of these rules. So what I should actually focus on only is the rule that's inside, which actually said that we have successfully parsed the entire array literal because the cursor is at after this curly brace literal. So yeah, we're done. There's two cases though where we got done, and I suspect that's why we have two separate parses of the tree. And then because the array literal was done, that also allows the expression to be done parsing, and then the expression, let's see, this was from step 4. So what the algorithm does is goes back to the table in step 4, I believe. 987654. So this is step 4. It's basically saying, hey, we were trying to parse this expression to match an array literal, and we actually finished it. We ended up finishing it, but it actually started here, and because of that, we satisfy an expression now. Yay! But who asked for an expression in the first place? We can look upwards in this table for chart 4 to find who was the instigator of this match on expression. And we look up, we can see it's actually assignment who instigated the search for an expression, because it reached this point, the cursor reached this point, and it says, I need an expression next. And that's the thing that started all of these tries to match one of these guys. Okay, so then because this expression completed, that means actually we completed this assignment symbol, which came from 0. So now we can complete the assignment matching which started from 0. So we go to chart 0. That's here. When you look for the rule that has assignment to the left, so that's this one, and that started from 0, so we can see that, oh, now we actually completed this assignment, and then we can see who instigated the matching of this assignment. Is walk back up this table, these entries, to see who instigated assignment. Oh, look, it was this guy. It was statement that did it, which means now that we've completed the matching of an assignment, we'll also complete the matching of a statement. And then now we can ask who instigated the matching of this statement. We go back up and so forth. We find that, well, it was here and here, both. So a statement tried to match a statement, and here try to match a statement. And then that will allow us to complete this, and then if there's like, yeah, it allows us to complete this, and then this can automatically complete because this white space is optional, so that completes this statement. Statements plural gets completed, and then we look at who instigated statements. Oh, here. So now we complete the program, which is the starting symbol. So we fully parsed a program. Okay, that was kind of a long explanation, but now let's get down to business. Try to figure out what actually happened to create sort of two separate parsers. So there's two separate program, two statements here that got, and when it completes, it actually copies that rule back over to here. So we can see that there's two paths for which program was fully parsed. So how did that happen is what I'm wondering. We can see that I think it might have to do with, although I'm not sure, but I think maybe it has to do with the way that these statements has two different paths. A statement can be, well, no, because there's two sets of both of these. Two sets of both of these. These look identical. So who instigated these? Both of them were from 0. So how did that happen? This is an early version of this, where before this cursor has advanced past this optional white space. So, and at this point, there were two versions of this. And again, this came from 0. Both of them came from 0. Although I wonder, I think intuitively, I think it has something to do with the array literal. So I suppose to test that hypothesis, we can change this to not an array literal. And then, oopsies. Well, actually, I'm gonna change it in this string here. And this one didn't create two results when it's not an array literal. So I still think it has something to do with the array literal, the way I did an array literal, maybe. And I'm wondering whether it has to do with the whitespace handling, because when you do optional things, like optional whitespace, that has the tendency of causing ambiguity, because so I'm going to remove the white space, and indeed, that kind of removed the ambiguity. Okay, so it actually has to do with the white space at the beginning here. So now I'm thinking it could be that the expression list already allows for white space, maybe. Although I don't actually see that. I don't see optional white space here. If I didn't put optional white space here, then I don't think it would allow for optional white space to be here. Oh no, I was wrong. It actually works. Even without me putting optional white space here, which actually is quite, I can't explain that unless expression. Huh. Oh wait, I didn't generate a parser, so that was not an accurate test. So right now, I think it will not parse. That's right, it didn't parse. So I do need that in order to have optional white space. However, I need to regenerate the parser. So now this will parse. However, that may give me, no, this one doesn't have a ambiguous grammar, but I guess if I add a white space at the end, then it has ambiguous grammar. Oh, that is true. Oh, so what is it about having white space at the end? Oh, because this is okay. I think I understand, but I will try to look at the parsing chart in a little bit more detail to actually explain what's happening. But I think it has to do with this white space because um, the way we do the way we have this null means nothing, by the way, which can often cause ambiguities. So nothing means just like you don't have to match any symbol, and it still matches whatever that is. So an expressionless is like, oh, you have an expression such as the number one, the numeric token, and then there's some mandatory white space here. I'll draw that out like that. There's some mandatory white space, which is that's two underscores. And then there's another expressionless. Well, what is an expressionless? Expressionless can actually be nothing. So if we don't receive anything more, then that works. This is a valid expression list. And I think that's where the ambiguity comes in. Is, well, okay, I could have parsed. So if you have a if you wanted to parse an array literal, okay, that means I first have an array literal. I have a left brace, and then I have a 2, and then I have a space, and I have a close brace. There's two separate ways to parse this. First is this. I parse this, and then so this is part of the array literal, but then this guy, I want to say that is a this is an expression list. How is that an expression list? Well, based on what we did before, that is an expression list because it's 2 is an expression. Is 2, and then it's got a mandatory white space. which matches this space. So we can say, and therefore this whole thing is an array literal. Okay. But another way this could have been parsed is different. Let me make some more black background here so I can draw over here. This could be parsed another way, which is that this could be parsed as utilizing this white space here. This white space could actually match this white space. So it can actually say, hey, this is an array literal because this one matches this guy, this one matches this guy. Now this white space is matched as this optional white space over here. And then this guy, this 2 here, that fits as an expression list. Why does it fit as an expression list? Because, well, an expression list can simply be one expression. And that's our 2. Okay, so these are 2 different parses of the same string, and therefore there are 2 ambiguous parses. I'm gonna verify what I just said. I hope from reading this chart. So the ambiguity came from based on what I am saying, the ambiguity came from the definition of the array literal and how it interacts with the expression list. It would have been nicer if we could sort of understood that simply by reading this table, but I understand like this table is a little dense, but nevertheless, I wanna get into it to try to understand what the parser is actually doing. So here we have sort of 2 different ways by which we have successfully parsed array literal, which it matches, it agrees with what I was saying. Now this is coming from 4, but the previous step, like we want to find the rule where the bubble was on this side, and that should be in the last, I mean, not last, but the previous step. So let's find those guys in the previous step. And that should be this one. Yeah. And this one. Yeah, that totally agrees with what I was saying. See, there's one version of the parsing of array literal where this bubble is before the dot. Oh, no, actually not yet. No, and then there's another version of it where the dot has advanced after the this optional white space. Actually, this totally doesn't verify what I was saying yet, because this advancement of this dot can happen immediately because this space is optional, and which is why this update happened. It just advanced the dot automatically because you don't have to match anything to advance it if this guy is optional. Okay, so I think we actually need to go back further. So let's go back to there's this one where the dot has already finished matching the optional white space, and then there's a different version where it is before this optional white space. Okay, I think that's where, and both of them come from step 4, so we move one back to see. I think at this point it was I think at step 16 that's getting a white space. yeah, step 16 is a white space, whereas step 15 was a string. It would be nice if we can actually see what token. So we can count. So token 1 is identifier, right? And then we have white space 3, 4, 5, 6, 7, 8. It'd be easier if let me do this. It'd be easier if we simply had one thing in it and we still have two separate parsers. Yeah. So let's go with this one. So in this case, there's, and I'm gonna remove the non-essential white spaces. So we have even less tokens, but still the same ambiguity. Okay, so now we're gonna have token number 1, token number 2, token number 3, 4, 5, and 6. Okay, and we have 6 tokens, and the 6th token is gonna be this closing curly. The 5th one is gonna be the white space. So we should have the exact same situation here, where we have 2 array literals that were completed. Yes, that's here. Oh, there's this one and this one. And then we go back one, and the 5th token is the white space. Okay, so we were able to match the white space in this mandatory white space rule, and that was matched for this optional white space. And I guess that allowed us to advance past this guy. So we have this array literal parsing that advanced the dot from here to here as the result of reading in this white space here. This array literal is starting a new one, so that's not the one we care about, but rather I think it's okay, it's this one, because this one is different. This one, the dot is still before the optional white space, and I think that the white space was consumed in a different place, probably. And namely, oh, namely, it was consumed by this. Oh, yeah, because we resolved the mandatory white space. This the resolving this mandatory white space allowed this expression list parsing to advance this dot from here to here, and which is exactly what I was saying before. So yeah, it allowed the advancement of this rule from here to here, which is basically taking the white space in as a separator within the expression list. Yep. I hope that made sense. So in one case, the trailing white space, then by trailing white space, I meant this one. The trailing white space in one case was used here, but in a different case was used here. So what can we do about that? Let me think. One way is just not allow this null, I think. If we're gonna say I guess the using this null was used in order to allow empty an empty list. So but the null comes with at the cost of, like, this white space could the trailing white space could either get matched here versus here, and that causes an ambiguity. So if we were to do it differently, maybe we disallow this null here and then have a separate rule or separate sub rule for array literal that allows for just a open bracket, an optional white space, and a closing brace, and that's a separate sort of matching rule for the empty array case. So let me show you what I mean here. So I'm going to remove this guy, and then this guy cannot be empty anymore. It has to have something in it. But we have a separate rule for matching array literal that says, well, an array literal can also just be that, and in which case we're gonna return well, let me do it longhand actually. It's gonna return something of type array literal items array, like that. So I think this will avoid the ambiguity. Let's see. Oh, I need to regenerate the parser. I have a syntax error in this code, I believe. Where is it? So it doesn't like this bar. Oh, that might be the wrong syntax. It might be the slash. I still have a bar. Where's my bar? Oh, no, it is the bar. There's something else that's wrong. What is it? Let me try again. On line 40. Oh, it's on line 40. That was not where I was looking at. Wait a minute. Syntax error at line 40, column 5. I don't see a bar there. What are you saying to me, nearly? This is kind of strange. Oh, this is a problem. Maybe it's that, but okay. It was this. It's very confusing that it gave me the wrong line number. I'm not sure why that happened, but okay. Okay, but anyway, that worked. And now if we parse the same example, we don't have an ambiguous grammar anymore. So that's an example, okay, of how do you debug ambiguous grammars. Just try to rewrite your grammar in a way that cannot be ambiguous, that there's in such a way that there isn't a way for it to interpret the same strings in two different ways. I guess for that matter, I probably should do the same thing for I'm not 100% that this is the best way to do it, actually. So I'm not totally sure. Maybe there's still a better way to do this, but I'm not sure. I have done this for other projects, and this is currently the best way I know how, I believe. But if I can think of a better way, I might switch to a better way. And this problem will probably surface again for function calls and function definitions at some point. But But let's see what happens. Because now it's impossible to call a function that takes 0 arguments after the change that I made. Okay. All right. So now what are we gonna do? Now I think with this, we can probably parse this guy. We can probably parse this guy correctly and generate an AST. Let's see. So we'll parse example array.x, and it generated an AST file. Let's look at it. It's here, and that looks good to me. And then, well, the next step is to generate a JavaScript file based on that AST file. So let's do example array.x.ast, and we're gonna. The generator says I don't know what to do with array literal nodes, so we'll go change that and make it handle array literals. So let's go to the generate script. So that is line 104. Yeah, that's right here. We'll just add another else clause for array literals. And then we'll say, well, I'll map its items. I think it's called items. Through this generate function, recursively call ourselves here. Assuming every item is an AST node that this generate function can also handle, this works out. And then we're gonna join them with a single, well, actually, we're converting it into JavaScript. So join them with a comma and a space. And so call these guys items in JavaScript space. And then we'll return a array notation in JavaScript, which is using the square brackets. So let's see if that worked. It wrote example array.js. Where is it? Oh, there it is. And it looks like this, and that looks correct to me. So now I'm gonna, I guess, to run this program now. Example array.x, and yeah, it prints out the array. So cool. That works. Now if we add the add some functions for the language to make use of arrays. Oh, I did that really quickly, but let me highlight I forgot to update my step. So I was working in the update code generator, and I think that just finished. Let me maybe test one or two things. Like what if we are let me test it a couple of things more, right? What if we have nested arrays? Is that supported in the language? Probably it will work, just because of the recursive nature of everything, but I'm gonna test it. Like that. So I have arrays nested inside this array. We run it, will it work? Yeah, it works. It works just like that. Okay. So we have arrays. We can have an array literal in this language now. We added the parsing for array literals, and we've updated the code generator to generate array notation in JavaScript. So it translates that code to this, basically. Now let's add map, filter, and reduce built-in functions to the language. In JavaScript, these are methods. The X language currently doesn't support method calls, only supports function calls at the moment. I'll probably add method calls later, but it doesn't have them now. So what we're gonna do is do it in the Python style, which is gonna look like you map an array, and then you provide a block, like so, which I guess in this language a block looks like this. I don't actually think we have a way for the block to take parameters yet. So it'll probably because I'm copying liberally from Smalltalk. So in Smalltalk, a block actually looks like this. In Ruby is kind of like this too, I believe. So if you write a block like this, then you can say like item times item. That this doubles every item in the array, maybe. So new array gets the result of this map, maybe something like this. In order to do this though, we'll need to support this syntax. I did not realize that, but yeah, I actually did not realize I have more syntax that I would need to support in order before we can do this. Okay. Should I either do this or I'm just gonna add these built-in functions with no way to access them right now. Yeah, let me do that. Although that's kind of unsatisfying though. So maybe I'll add them and then maybe we'll implement this syntax as well. Maybe it will need to be a quick and dirty thing. So I'm gonna work on the built-in functions, which I think that's in the generate order. Yeah. Okay, a map function, assuming it takes in an array, you just take the function iterator and pass into the arrays the map method like that. So that there's our map and there's our filter. And reduce, we can do the same thing. Reduce has an initial value. Like that. Okay, very cool. We have these functions, but again, we probably have trouble using them right now, but you know what the heck. Maybe we can do each. Yeah, let's do each. Each, at least, should work. Should be usable. Okay, so if we did each, then we can actually print. Oh, we can't. Unfortunately, we actually can't. We can print a constant though. Okay. Alright, let's try that. Oh. There isn't supposed to be commas in this language. Yeah, we print hello 6 times because there are 6 elements in this array. I'll make that clearer. 1, 2, 3, 4, 5, 6. It'll print hello once for every element there is in the array. Okay, so why don't we implement this parameter syntax for blocks? Why not? So I didn't want to implement it like an arrow function because I didn't like the fact that there could potentially be optional white space here, which kind of doesn't jive well with us trying to use mandatory white space to separate values. So I am actually gonna bring in some inspiration from Smalltalk. Smalltalk blocks look like this, and then Ruby kind of copied this thing. So let me look at what Ruby code blocks look like as yet another data point. So Ruby code blocks, there's two different syntaxes for Ruby code. It can either be delimited with these braces, and then you put the parameters inside this little delimited with the bars like this, with commas like that. Or you could write do n again with these bars delimiting the thing. So I could do it like Ruby or do it like Smalltalk. Smalltalk doesn't have this bar on the left, whereas Ruby does. I think I'm more used to Ruby's syntax, which looks like that. But the Smalltalk syntax looks a little bit. Smalltalk syntax, does it have a little colon in front of it or something? I don't remember. Maybe go with the Ruby syntax. So something like this. So that there's a parameter list to the code block, like that. And that's what the code looks like. And then within here, we can say item. Let's go for this. Why not? Okay, so let's add more syntax. So we're gonna change the code block. So the code block can look like this, or it can have this optional, I'll call this code block parameters. And yeah, which come before, there can be optional white space before it. Okay. And okay. And if we had this, then so code block can have parameters. But these indexes have changed. So this guy is going to be index 2, 0, 1, 2. But the statements are actually 2, 3, 4, 5 now. And then we need to define what code block parameters are. So code block parameter is a bar. The lexer also needs to emit a bar, which it currently doesn't have. Should I just call this bar? Okay, bar. Okay, so you're gonna have a bar and then another bar, and then within it we have expression list. This actually, and let's just say it's not allowed that you have nothing inside the bars. If you're gonna have nothing inside the bars, just don't use the bars at all. That way I don't have to do this approach that I use in the other place. Okay, so and okay, so this is what code block parameters are, and here I'm gonna return I think I'm actually going to just return the array that's returned by this expression list, which is at index 0, 1, 2. Okay, let's see if this works. I'm gonna run gen parser. Let me try parsing this file here. Example array parse array.x. Ah, it did it. So we have a AST file that has this function call, and then let's see. I have a code block that has parameters now, which is an item in this case. Okay, code blocks can have parameters. This will have repercussions though, because my function definition has a code block in it. And the function definition actually looks more like this. So now we're saying, hey, you can actually do parameters like this, which is kind of weird. It seems like we should pick one and go with it. And maybe what I do is just like say, you know what, define a function like that. Or maybe like that, or maybe like that. I don't know. So we'll figure it out. We might change the language shortly after. We might change the language, or I don't know. I don't know what's the best solution here. But in any case, that has some negative repercussions, what we've chose to do here, which we'll need to clean up later. Oh, I forgot to update my sub-goal label. Sorry. So I've actually completed all of this. I completed the add map filter function, and there's an extra step that I'm doing, which is add params to code blocks, and that's actually what I'm doing right now. Sorry about the noise. Okay. So we have code blocks parsed. Now, in order to generate it, again, we'll need to, in order to have it run, we'll need to update the code generator. Code generator, singular. Let's try that. Oh, it did it, actually. That was unexpected. Oh, because currently it just ignores the parameters. Currently it didn't put item in here. So we really need to put items in there, and we can get the generator to do that if we look at the code block here, and if we say, hey, oh, it's this function, so params. So I'm gonna get a params in JavaScript space and say note that parameters that map over the generate function and join it with commas, and then these params are going inside of this function. And at this point, I think that should work. Let's look at this example array.js, and yeah, we have the item parameter here now, and I guess we can run the example array.x now, I think. Yep, it's printing it, but we can do maps as well. So let's do map. Let's do this as a map, and then we'll print the new array. everything is undefined. Oh, because we're not returning anything. So let's. Oh, I don't have a return statement. I don't actually have a way to return things because there isn't a return statement in the language at the moment, and that's embarrassing. And I also don't have a multiplication. That's right. But that's done with mul, the mul operator. But yeah, I can't return because return. Oh, I haven't written the parser in a way that supports return. I might support implicit return. That's a possibility. So we still can't do map just yet. Perhaps we defer that to the next episode. So at least we can do each. So we can do something like this at this point. Yeah. So in order to get map to fully work the way it's intended to work, we're gonna need to either implement return statements inside of a block, or to implement in implicit returns, which just means like whatever is your last line inside the block, you implicitly return its result. So one or the other, we'll probably do it next time. At least we have some resemblance of arrays working at this point, and that's something to be proud of. And yeah, we'll call it a day here, and I'm gonna end the stream, and I'll see you next time.